In this video, we will learn about distance time graph. So the distance time graph shows variation of distance covered by an object with time. For drawing distance time graph, we take time along the x-axis by adopting a suitable scale of our choice. Similarly, distance is taken on the y-axis. Distance time graph can be drawn under different conditions as discussed below. When the object is at rest. So for the object at rest, the position of the object remain fixed and does not change with time. Let initially at t equals 0, the object is situated at 8 meter from the chosen origin O. Okay. Now, the object will remain at s equals 8 meters for all the time to come, and hence the distance time graph is a line AB as shown in the figure. Obviously, for an object at rest, the distance time graph is a straight line where AB is parallel to the time axis. Another could be when the object is in uniform motion along a straight line. So if an object is in uniform motion along a straight line, then the object travels equal distances in equal interval of time, or its speed as well as velocity are uniform. It means that the total distance traveled by the object is directly proportional to the time taken. Okay. Therefore, for uniform motion along a straight line, the distance time graph is straight line OAB, which is inclined at a constant angle from the time axis as shown in this particular figure. Now, we can determine the speed of an object. So, we can use the distance time graph for uniform motion to determine the speed or magnitude of velocity of a given object. For this purpose, we consider any two points A and B on the graph. Let this A and B are the points. Now, these corresponds to t1 and t2 time respectively. Now, the values of the distances can be s1 and s2 from these points. Now, as shown in the figure, draw a line parallel to x-axis from point A. Now, from point B, draw a line parallel to y-axis. These lines will meet at point C. Okay. Now, they form a triangle like this, A, B, and C. On this graph, AC denotes the time interval T2 minus T1. So, this is T2 minus T1. And BC denotes S2 minus S1. Right? As the object moves from point A to point B, it covers S2 minus S1 distance in T2 minus T1 time, right? Hence the uniform speed or magnitude of uniform velocity can be S2 minus S1 distance covered upon total time, that is T2 minus T1, that is BC divided by AC. Now the term BC upon AC is known as slope of distance time graph for a uniform linear motion. Thus, we can say that slope of distance time graph gives the speed of a moving object, right, or the magnitude of velocity. Now in the figure you can see that AC is equal to 40 minus 20 seconds, that is 20 seconds, and BC is equal to 20 minus 10, that is 10 meters, right? Hence the uniform speed, that is BC upon AC, would be 10 meter upon 20 seconds, or we can say 0.5 meter per second. So this is how you can calculate the uniform speed by a graph, or specifically the distance time graph. Now the distance time graph of an object in non-uniform motion. We know that motion of an object is said to be non-uniform if it covers unequal distances in equal interval of time. Now the following table shows distances covered by two buoys R and S along a straight line with time. Now from the data in the table we can plot the distance time graph for the buoys. Distance time graph for buoy R, that is this graph, shows in figure 2, and for the buoy S is shown in the figure 1. This is figure 1 and this is figure 2. It is clear that the shape of this graph is not a straight line. Now, we can say that for a non-uniform motion, the slope of a distance time graph varies from point to point. I hope this topic is clear to you. Thank you.